Hello students, welcome to IMS Academy. In today's session, we are going to discuss EDC previous year question papers. I selected GATE 2019 ECE paper. The problems which were given in EDC that I want to discuss here now. Very few number of problems are there, those questions I will discuss now. Easily you can understand. The question here given, which one of the following options correctly describes the equilibrium band diagram at T equal to 300 Kelvin of a silicon Pn here given Pn n plus and P double plus configuration shown in the figure. But here you should understand well about the p-type and n-type energy band diagram, how to plot. Based upon that ones, you can draw. Which one is the right also, you can give clearly now. Suppose you have taken any p-type semiconductor here. I will do here now. Suppose I selected p-type extrinsic semiconductor. P-type extrinsic semiconductor I selected, for example. But how the energy band diagram will be plotted for p-type extrinsic semiconductor? Suppose I selected this as a conduction band EC. This is nothing but the valence band EV. EV we know very well. And the EI is nothing but EFI is nothing but Fermi level in the intrinsic semiconductors will lie exactly at the center, you know that now, approximately at the center now. But in the p-type extrinsic semiconductor, where EFP means Fermi level energy of p-type extrinsic semiconductor, it lies very close to the Fermi level, EV, it is very close to the EV only now. I can draw like this. EFP I can write. The Fermi level energy in p-type extrinsic semiconductor I can put such a way. Where EFI, it is approximately at the center. EFI I can write. EFI. This is EFP. For p-type extrinsic semiconductor, this is to be taken here now. In case I asked, can you draw energy band diagram for the what? N-type extrinsic semiconductor, I asked. N-type extrinsic semiconductor. For N-type extrinsic semiconductor, I can draw a diagram like this. There is a conduction band EC, there is a valence band EV. Where Fermi level in the N-type extrinsic semiconductor will lie, it goes very close to the conduction band. It goes very close to the conduction band. EFN I can write Fermi level in N-type extrinsic semiconductor. Thirumala Reddy, good evening. Good evening. Yes, I can draw EC here, EFN comes here now. But EFI, where it can exist, approximately at the center I can write EFI. I can write this EFN. If it is taken p-type and n-type materials separately, EFP below and EFN at the top, they will not be on the same axis here now. Suppose you combine p-type and n-type materials, you think it's so. It won't come. The p-type, the EFP below and EFN above, it won't come now. On the same axis it comes, both will be aligned together now. EFN and EFP will be aligned if it is taken single specimen here now. So here, just now I explained how the energy band diagram for the p-type extrinsic semiconductor, how the energy band diagram for the n-type extrinsic semiconductor. Now the given problem we can take. There we can draw, here I can draw energy band diagram for that. What's given? Pn here given Pn I will put here now. Pn, and also what is given? Pn, n plus p double plus, n plus p double plus, n plus p double plus. Such a way question was given. P double n and p double plus is given here now. P double n, p double plus. N plus indicates it is moderately doped. P double plus indicates heavy doping is made. If not given any plus for the p type and n type here now, it is a lightly doped only. Understand my point now. I said here now, this is one of the material. This is one of the material only now, totally. These are all combined and one material, one specimen is formed. Now, the Fermi level energy of p type or n plus and p double plus must align on the same axis only now, align on the same line. Then only it is a perfect only now. How I will draw, you please watch. Initially, I selected lightly doped p type semiconductor I have taken here now. How we can draw this diagram? There is conduction band EC and there is a valence band. Where that Fermi level will lie in p-type extrinsic semiconductor? It lies very close to the valence band. Just now I explained you, please watch. EFP, it lies close to the valence band. That I want to use here now. Yes, it is very close to this. But generally, I will put here a EF itself. EFP, EFN, EFN plus, EFP plus will be on the same line only now. I can extend because the line will be aligned on the same axis only here now. That I can extend as this only. This is for P type, I said. It is a lightly doped only. Lightly doped means the distance will be somewhat more. Suppose the P plus is given, you think so EF will come very close to EV. If it is a given what now P double plus is given, you think so it can penetrate inside of the what now EV also. It can penetrate inside of the what now EV only now. That is possible here now. Next one is the N-type material. In the N-type material, where Fermi level will be there, it will lie very close to the conduction band given here now. In N-type extrinsic semiconductor, Fermi level will be very close to the conduction band. It is also lightly doped. So I can say for a N-type material, for this material, for N-type material, but this Fermi level will lie very close to the conduction band. Very close to the conduction band only now. Same Fermi level. Initially, Fermi level is very close to the valence band because the p-type extrinsic semiconductor. Because of the n-type extrinsic semiconductor, it is very close to the conduction band. It is very close to the conduction band only now. But it is away from the valence band only now. This Fermi level will lie away from the valence band. I can draw like this. This is the valence band here possible. Away from the valence band. This is n-type. I selected n plus here now. N plus is the next one. In the n plus, okay, just wait. In the n plus, this Fermi level will lie very close to the band. What band? N plus indicates it is a moderately doped. The Fermi level will be very close to the what now conduction band. Very close only now. Very close means I can draw close to this. It is somewhat distance. It is very close only, you can say. That is n plus, I can say here now. This is nothing but n plus. But this Fermi level will be far away from the valence band. I can put like this. Far away from this body. And P double plus indicates it is heavily doped. This is heavily doped. In the heavily doped p-type extrinsic semiconductor, the Fermi level where it can exist, that will be where it can exist. It can penetrate inside of the what now valence band. It can penetrate. That means the valence band will be below or above is possible. This is the valence band, you know very well. In this case, this is the conduction band. But in this case, P double plus indicates valence band will be just above this Fermi level. Just above this Fermi level only possible. Valence band is here, but it will go down only now. But why it is going down means it is heavily doped only. But conduction band will be far away from this. Conduction band is far away from this. Now we can combine these points. It comes like this. We can combine these 2 points. We can combine these 2 points. The finally energy band diagram will be like this only now. This is the energy band diagram. And where EFI will be existing, there is exactly approximately at the center we can say EFI. This is EFI, Fermi level energy in intrinsic polynomial. And it goes like this. It will be at the center. It will be at the center only now. And slide bending is made here now, slide bending here now. And slide bending here now. And it goes like this and moves in this way. That way it goes. This is the energy band diagram. Energy band diagram. That way we can draw. Which option is correct from the given options? We can check. These are all the 4 options are given here now. Which option is right? Anybody? I said already because of this P double plus, because of the P double plus, what I said? Because of the P double plus, the Fermi level can penetrate, it can go below the what now? Valence band only now. Below valence band only, it is there now. You was here now, this is going this side, it goes, that means this is the valence band we got here now. Below valence band only, you got EF. Below only now. That's why this option is correct only, we can say. Option A is correct. But these are all not given just above the what now, EV is not above the what now Fermi level in other cases only. 100% this option is correct from the given problem. Understand? I hope you followed this question. And I will do the next question here now. This is the next question. Anybody can give answer for this question without my help? But I want to wait for some time. Any student can give answer for this question. Which option is right? I gave there 4 options. Which option is right? Anybody can give answer? But I want to give you time. Please try this. You take time and give answer. Any student can give answer for this question? I would like to know how many students can give answer for this question. Same GATE 2019 question. The correct circuit representation of the structure shown in the figure is, the structure is given, 4 options are given. Which option is right for the given structure? That is needed. Anybody? Now you try to catch here now. This is the given structure. B indicates base, E indicates emitter, C indicates collector. Base, emitter, collector is given. But in this structure you watch, the collector is given with N double plus. N-type semiconductor, here it is existing. Emitter, if it is taken, you got, this is a heavily doping, N double plus, this is also N-type extrinsic semiconductor, emitter also. What about the base? Base, here P, this is a N, base is existing between P and N. The base is in between the P and N. Base and emitter, if it is taken, P and N possible. Collector and base, if it is taken, N required. You can identify from that. But here the 4 options are given. Here you watch, one is a NPN transistor here. This is given NPN transistor. It is a PNP transistor here given. This is NPN transistor. This is PNP transistor is given. And these are the transistors are connected with diodes. Now you catch. In option A diode is connected. This is nothing but the P-type semiconductor. Arrow indicates P-type material. Line indicates N-type. This is P. This is a P only now. This is a P-type. Line indicates N-type. P and N. This side, this is the P-type. Line indicates N-type. Here also I can take this is a P-type here. This is nothing but N-type. This is a P-type. This is N-type you got here now. Now you can understand clearly now which option is right. The collector is with N-type material. Collector is with N-type semiconductor only now. Yes. Where we can find collector with, this is collector, this is also collector. These two are what? These two are with N-type materials only. These two are with N-type materials only. But if it is a P-type extrinsic semiconductor, this is going to be, collector is going to become a P-type material. This is going to be P-type material. So these two are not correct. Out of these two, one must be correct only now, because these two collectors are N-type extrinsic semiconductors only now. And next one, you watch, emitter is N-type. Emitter is N-type. This emitter also same N-type only, no doubt. Now please watch, collector and emitter, if it is taken NN, collector and emitter is a NN. Collector is N, emitter is a N. Collector is N, emitter is N. Both are N only now. N-type semiconductors only. Next one, base and emitter you watch. Base and emitter, P-type and N-type. Base and emitter with P and N. The base is this P-type, same P-type here now. P-type, emitter is a N-type. Yes, it is a P and N-type only now. But here, what now, base and emitter you watch now, base is N-type, emitter is a N-type. But as per this question, P and N, base and emitter with Pn only now. Here Pn I am getting here now. 100% option A is correct, we can say. Even you watch the base and collector, base and collector, base and collector, N-type and N-type. Base and collector, N-type, and here also N-type, exactly satisfying all the conditions only now as per the given structure now. So option A is correct for this question only, we can say. Such a way we can tackle this question. I hope you followed. Anybody having any doubts regarding this? The next question I will go, finally which option is correct? Option A is correct here now. Solution is solution A is A. A is correct, I can say. That is the required solution. Next question, I want to give one more question here now. The one more GATE 2019 question. Anybody can give answer for this question? Any student? But I want to check how many number of students can do this question without my help. Without my help. Can you complete this question? Anybody? Anybody can give answer for this question? GATE 2019, 1 mark question. But I want answer from your side. Anybody can give? Anybody can respond? Yes, The figure shows the high frequency CV curve of a MOS capacitor. Is a CV curve of a MOS capacitor at T equal to 300 Kelvin, it is given. With phi ms equal to 0 volts and no oxide charges given here now. The flat band, inversion and accumulation conditions are represented respectively by the points. Here I want flat band, which point? P, Q, R, 3 points are given. Which point is said to be flat band? That is more important. Manoj Kumar gave option B. Option B is 100% perfect, flat band. Next one is nothing but the inversion. Third one is nothing but the accumulation conditions. They are represented only now. Here from the given diagram, you can see clearly certain points I want to give. From those points, you can identify easily solution. From this diagram, if gate potential is given less than 0 voltage, you think it's so. Less than 0 voltage. That is called as a, which one we get, accumulation mode only, we can say. There is an accumulation possible. That's why we can write one point. If for gate voltage, for VG is less than 0, you think it's so. Gate voltage is less than 0 voltage. In that case, accumulation occurs. Accumulation occurs. Accumulation occurs. That means that the P point comes under the what now? Accumulation only now. VG is a less than 0 if you maintain accumulation. The point P is said to be accumulation only now. That can be taken as a accumulation. That can be taken as a accumulation. Occurs only now. That is a point B. I can put here now. That is point P. I can note down here now. Suppose you are maintaining here now, as per the given diagram, VG equal to 0 voltage, it is maintained now. If VG equal to 0 voltage, if it is taken, that is called as a flat band. Flat band happens. For VG equal to 0 means the flat band happens. Flat band happens. The flat band happens means I can write point to Q point only it comes. This is nothing but accumulation. The Q point is said to be what? Flat band only here now. That is a flat band. In case VG is greater than 0, that point comes R point. That is called as a what now? Inversion only now. For VG is greater than 0, we can write inversion happens. Inversion happens here now. Happens. For the second case, which point we can take? This is a Q point I can put here now. Third one is nothing but the R. Like that, points are possible. Now you please watch here given the flat band. First one is a flat band. Flat band is what? Flat band is a Q. Flat band is a Q. Answer solution I can put now Q. Second one is a inversion. Inversion indicates R. And third one is the accumulation. Accumulation indicates what? P point only, we can say the points. This is the solution QRP. QRP is nothing but the option B I can put here now. So these are the problems from GATE 2019. So this is the question from the EDC 5 years papers I did now. The tomorrow onwards I am going to start the analog 5 years paper 2023 and 22 and 21. But there I will take the 1 hour correctly now. Why means here only from the ECE paper I can collect the questions only now. In the analog I can collect the questions from the IN and also electrical and also from the EC and also from the ECE. From these 3 branches we are going to get the more number of problems. That's why we can do here number of questions from the analog from tomorrow onwards now. Try to attend and try to get some idea about the analog circuits now. You can tackle any sort of problem easily if you attended the class tomorrow. Okay then, thank you.